Multi-millionaire businessman David Morgan and his wife Pally have flown from California to Kansas, USA to spend $14 million.
Very excited.
Oh my gosh, there's so much anticipation.
They're here to take home their very own Learjet 60XR. For David, it's a dream come true.
I just pinched myself to say, this is actually happening.
For David to be happy, 2,500 workers need to assemble, flight test, paint, and deliver, on time, the perfect jet.
Wow.
Learjet is synonymous with high-flying luxury. Renowned for their sleek, lightweight airplanes. The 60XR symbolizes their expertise. Hand-built here in Wichita, Kansas, USA. This is aviation's equivalent of a Formula One racing car.
This is innovation. This is excitement. This is speed. This is really cool.
Learjet created the very first business jet. The 60XR builds on that legacy. This flying machine cruises at 51,000 feet, 30% higher than a commercial passenger jet. Its two Pratt & Whitney engines generate the equivalent power of 12 Bugatti Veyrons, pushing it through the high thin air at 861 kilometers per hour. It's so efficient, it can fly Los Angeles to New York in under 5 hours on just one tank of gas. This plane combines the aerodynamic efficiency of a supercar with the power of a jet fighter. These unique attributes attract big business. David Morgan runs his own multi-million-dollar company with offices and customers around the globe.
The Learjet enables me to be face-to-face with my customers, wherever that may be, at a moment's notice.
We give people freedom to do what they want, when they want.
Learjet is part of Bombardier Aerospace, the third largest civil aviation company on the planet. The 60XR is unique in Bombardier's global family. It's the only plane manufactured on one site. Here at Learjet's Megafactory, smack in the middle of the United States.
Being able to come to Wichita, Kansas, walk through one factory, and you have an entire product, this is rare.
It's a fact that technical engineering manager Lyle Bynum appreciates.
At Learjet, the 60 is produced here because it requires a certain technical knowledge to be able to produce a good product every time.
Established in 1962, the factory has expanded from just one building to a series of specialized units. Together, they've produced each of Learjet's state-of-the-art aircraft. It's a brand known across the globe. For 5 decades, Learjet has been a status symbol of the rich and famous. But this doesn't mean the company's secure.
Bombardier Aerospace says it is cutting 1,360
demand has
jobs.
deteriorated rapidly and now expects to.
The worst economic crash in 80 years shook it to the core. Vice President General Manager Ralph Axe was under no illusion about the threat Learjet faced.
It was a tough period for not just us, I'd say aerospace worldwide. You know, when something like this happens, it really forces you to look internally, because I can't control the outside world. So what I can control is what we can do in our 4 walls.
This megafactory had to evolve to survive.
We've done some real phenomenal things over the last period of time.
First was computerization of the entire production process.
It has really helped the build process and has made much easier to be able to manage it and make sure that the mechanics have what they need when they need to build the aircraft.
Before computerization, each mechanic was expected to pick through thousands of parts to complete a build. Now, that mechanic receives only a small daily kit of parts and logs the completed job on a digital workstation.
This tool enables us to manage it. At every 6 minutes, it updates. So every 6 minutes, we know exactly where the build of the aircraft is.
The architect behind this transformation is Vice President of Strategic Projects, John Deaker.
We get a daily amount of work brought to the force today, allows us to be more productive in what we do, allows us to control the chaos, if you will. It gives us transparency through the organization, and everybody knows where we're supposed to be and when we're supposed to be there.
The company also realized the actual environment needed modernizing.
As we walk through our factories today, you see an environment that's much different than it used to be.
We've painted all of our floors, we've painted all of our jigs, made everything color-coded.
It's cleaner, it's brighter, it's more organized.
This is not just glorified interior design. It's had a dramatic effect on the workforce.
It changes your morale and helps us meet our goals.
You know, if people are working in an environment where it's not bright enough, they can't really see things, their morale is down, they're not really understanding why they're maybe working on things, they're not as engaged. At the end of the day, you know, that's affecting profitability.
We have taken the opportunity of the recession to actually redefine the process of how we do work at Learjet.
To build customer David Morgan's plane requires over 48,000 components. 65% of them are made here at the factory, and most start as a single sheet of aluminium alloy. In the Aerostructures building, high-grade aluminium alloys are the key to Learjet's lightweight designs. This metal is a third the density of steel and almost 3 times as strong, yet it's also capable of flexing, allowing the aircraft to breathe, contracting as it climbs, expanding as it comes back down. A computerized drill and route machine can mark up to 500 different components from this sheet alone. This particular piece is a rib, destined for the fuselage. It's sanded to ensure a consistent finish, before transformation from 2D cutout to 3D component. Placed on a form mold and covered with a protective rubber sheet. It's fed into a hydro press, where hydraulic fluid forces the cutout section to form around the mold. The rib is then tempered in an industrial oven at 900 degrees for 30 minutes. The heat optimizes the alloy's internal structure. Then the cooking process is stopped at just the right point with a cold bath. The parts are then dipped in a series of chemical baths before being sprayed with a distinctive green primer, all to protect against corrosion. They're finally carted off to a component warehouse, ready for distribution across the factory. Learjet was founded 50 years ago, the vision of one man, Bill Lear. Each jet still bears his name.
Bill Lear invented that airplane, especially for movie stars and successful businessmen to be seen in. So it created the term the jet set.
Invention and an entrepreneurial spirit were in Bill Lear's blood. Before Learjet, he'd invented the car radio, naming it Motorola, his first mega brand. Next was another untapped market, private business jets.
His idea was to get owners and operators from one point to another very quickly so they could still conduct business during the day and then fly back home and be able to have dinner with the family that evening.
He searched for an aircraft designed to adapt. As the 1960s dawned, he found his plane, the P-16, a Swiss ground attack fighter.
Bill Lear was really excited about the performance of the wing on the fighter jet. It's a good combination of high-speed performance and low drag, as well as good controllability during takeoff and landing.
He acquired the rights and in 1962 set up shop in Wichita. A year later, the first Learjet took off. Bill Lear's dream had become reality.
Bill Lear had a very simple philosophy, and that was if it looked fast, it probably was fast.
The 60XR is a direct descendant of that first fighter-inspired jet.
When we designed the Learjet 60 wing, we took the early Learjet and we added a 6-foot extension.
The added length is necessary because the 60 weighs nearly double those early Learjets. Impressively, Lyle Bynon and his team still managed to keep this wing the smallest in its class.
Because surface area is proportional to drag, this is a very efficient wing because of its size.
The Learjet's wing is also built in the Aerostructures building right next to component manufacture. This is the heart of the factory. As the wing shop's logo states, without us, it's just a bus. The entire span of the wing is built as one section over 5 positions. First, a vertical spine with 6 horizontal spars is assembled in a jig. This embryonic wing skeleton reveals the 60XR's fighter plane DNA.
Okay, this is what the 60 model's all about. It's got 1, 2, 3, 4, 5, 6 spars. It will move to the next position where it'll get 2 additional spars. It'll have an 8-bar total wing, very heavy duty. That's good.
The 8 spars, originally designed to support weapons, gives this wing the performance of a military fighter. The wing is so strong, it can flex almost 2 meters up and down at its wingtips. This wing also has another surprising function. It's a 1,600-liter fuel tank. With the upper skin of the wing attached, every rivet and bolt head needs to be sealed to create a fuel-tight tank. The smallest of leaks could be catastrophic. Technicians use a specially developed sealant that withstands the corrosive nature of aviation fuel for the plane's entire lifespan. One man with a personal interest in this wing's build quality is Grant Opperman. He's company president of customer David Morgan's business.
Wow, look at this.
As company president, Grant's going to be using this plane for business a lot.
This is the wing for our airplane right here. Hey, Steve, I'm Grant.
How you doing?
Nice to meet you. You made our wing for us, huh?
Yes.
This is amazing. You know, I mean, the rest of the airplane is what you think about, being in the seat and looking at the cockpit, but this is really the only thing that's keeping us up in the air and safe. It's scary and reassuring at the same time.
With the upper skin and frame sealed, the lower skin is craned into place. The assembled wing spans over 13 meters. Its V-shaped geometry is extremely aerodynamically efficient, increasing lift, the force that keeps a plane in the air, while decreasing drag, the force that slows a plane down. And there is an additional design feature, pioneered by Learjet, that reduces drag further still. The winglets. These vertical wingtips are fitted to either end of the main wing structure. As high-pressure air traveling beneath the wing curls around the wing tip and into the low-pressure air traveling over the wing, it causes a vortex, or mini-tornado, that creates drag. The fitted winglets form a barrier, breaking up the vortex and the drag, giving a smoother ride and increasing range. In a final bid to reduce drag, Learjets are designed to fly high, where the air is thinner. But there's a drawback. Up here, temperatures dip to minus 45 degrees Celsius. This can lead to the wing's leading edge icing up, which adds weight and disrupts airflow, both potentially fatal. To prevent this, a drilled titanium tube, known as a piccolo tube, is fitted the length of the leading edge. Hot jet exhaust gases are diverted into this tube, escape through the drilled holes, heating the polished leading edge and preventing ice formation. With the hydraulic systems and landing gear installed, this wing is ready to meet its fuselage. The fuselage is taking shape in the same building, alongside wing assembly. The fuselage build starts with construction of the main engine mount. This beam withstands the 9,200 pounds of engine thrust. It's built into the aft section of the plane.
This is the baggage compartment back here, and this will be the fuel cell. And this is like where they fill the fuel.
The supporting framework is made from vertical alloy ribs, the component manufactured earlier, and horizontal aluminium struts, known as stringers.
Eventually we'll add our skins, and then it'll move up the line.
The aluminium skins are first held in place using temporary fasteners, checked, then permanently riveted together. The 60XR is hand-built using 43,300 rivets. Hand riveting requires two technicians working in tandem. Performed with skill, riveting keeps joints watertight, airtight, and also allows for metal expansion and contraction. The fuselage actually contracts by 9 millimeters as the plane climbs to the 51,000 feet it cruises at. The completed aft section is then craned down the line and positioned into the main jig, ready for the forward section to join it.
Coming down. Yeah.
The 60XR's windshield has arrived from a specialist manufacturer in California. Herb Bailey is Learjet's longest-serving employee. For 46 years, he's kept pilots safe by searching for windscreen defects.
There's some distortion in every windshield, but not very much, and we don't allow very much. If there's distortion in this windshield, those grid lines are going to be moving around.
This windshield is just over 30 millimeters thick. It's composed of 5 laminated acrylic or plastic layers with an ultra-thin gold heater film sandwiched between them to stop fogging.
The Learjet 60 windshield is one of the largest windshields on any business jet. It also has a very sharp angle. If the airplane were to have a bird strike, that helps shed the bird and minimize the damage to the windshield.
Birds are a plane's worst enemy. A bird strike can have catastrophic results. Civil and military aircraft are routinely lost. So the Californian manufacturer shoots dead chickens at its windshields to test there's no penetration. It's a messy job, but someone's got to do it. With the windshield installed, the cockpit is craned over and shoehorned onto the nose section. Behind the nose, the cabin is created from pre-assembled panels, which are slotted together and riveted in place. This is the only Learjet cabin that's high enough to allow an adult man to stand up inside. The completed forward section is cradled into a sling, hooked up to the overhead crane, swung across to the main jig, and mated to the waiting aft section. The tail assembly is reaching a critical stage. The horizontal tail plane is about to be bolted to the vertical fin. The two are attached using a hinge pin. This allows the tailplane to pivot, enabling the pilots to optimize the aircraft's handling in flight. To minimize the amount of free play in the joint, the carbon steel pivot bolt must be shrink-fitted. It's supercooled to minus 79 degrees Celsius using dry ice. Time is now of the essence.
From the time I pull it out, I've only got 14 seconds to install it before it swells up again.
If this $700 bolt is not inserted within the time limit, 2 watching inspectors will fail the assembly. With the production line waiting, that's a costly error, and David Morgan won't get his plane on time.
All right, here we go. Yep.
Better go. 7 seconds, so it's good.
All right. That's a good pin.
With the aft and forward sections mated, it's time to crane the completed assembly off the main jig and onto the factory floor.
I'm the man. The man running the crane has to make sure that we don't damage the aircraft, because this is a pretty high-dollar aircraft. All right, guys, going on up.
The 17-meter fuselage is hoisted off the jig and swung forward into its penultimate position.
We got it. We're down. Let's undo the forward strap.
Once the fuselage is safely down, the tail assembly can be mated. Finally, the wiring bundle controlling every electronic function in the plane is installed. All 24 kilometers of this wiring has arrived from electronics. Here it's mapped out and tested on form boards that represent the aircraft's wiring layout.
Our job is to make sure that everything is in here correctly. Because if we have any problems, it's easier for us to fix it than it is for the guys to do it out on the aircraft.
Connecting, soldering, and testing this harness of over 6,000 wires takes a week. Once finished, the bundle is taken off the form board, bagged up and carted straight to the waiting fuselage for fitting. Originally, all Learjets were manufactured and completed under one roof. Over time, the factory outgrew this space and the production line split into newly acquired buildings. It means that the finished fuselage and wing must be hauled across the site, from aerostructures where they're built to final assembly. All aircraft are joined together in final assembly. The fuselage is raised to allow enough clearance before the waiting wing is tipped on its dolly, wheeled underneath, centered, and leveled. Squaring up a 13-meter wing while lowering a fuselage the weight of a Rhino isn't easy. But if the manufacturing jigs have done their job, each of the connections should meet exactly. Only 8 bolts secure the wing to the fuselage. 2 nickel alloy bolts, able to take the weight of 5 elephants apiece, are the main connectors.
You got to make sure this is in 100%. If not bolted down, this wing will fall off, and we don't want that.
That's good. Go ahead and pin the other side.
With the starboard side bolted, the technicians use brute force to hammer the port side bolts home. Of these other smaller 6 steel bolts, only 4 are actually required. 2 are for backup only, in case of failure.
After it's seated properly and bolts torqued down, it's a beautiful thing.
Meanwhile, in the engine shop, an electrician is making final adjustments to the engines that have arrived from Pratt & Whitney in Canada. Each engine weighs the same as one Harley-Davidson motorcycle, but produces over 100 times as much power. A special fitting called a shock banana helps stop engine noise and vibration reaching the cabin, giving a quieter ride.
Bring it in a little bit.
Whoop. 2 nickel alloy bolts, costing over $800 each, take the strain of the engine's thrust and cope with the extreme operating temperatures. A further 2 carbon steel bolts are fed through the close-fitting parts before being tapped home and bolted tight. These are the only connections stopping the engine rocketing away. This plane is now ready to fly. It leaves final assembly bound for production flight. Just a short trip across the ramp. Arriving in production flight, there's still a lot of work to do before David Morgan's plane is ready for its maiden voyage. Reputation is paramount. One crash, and businesses would stop buying Learjets overnight. Engineers meticulously check everything is correctly assembled. Once satisfied, they release it to avionics technician Glyn Macias, who puts it through its paces on the ground.
People's lives are involved, and you know that you've got to do the best job that you can in order to release a safe, airworthy product. It's a real challenge. You might have a autopilot disengaging to something within the computing system. We'll bring it out to a run-up area and check engine performance. Go on up to takeoff, and engineers will look that data over and ensure that we're turning a good product over to the pilots.
Despite spending his day in the pilot's seat, Glyn is realistic about his flying abilities.
I'm pretty confident I could take this thing off, but I don't think I would be too comfortable knowing I have to come back down safely.
The 60XR has passed every test.
Good job.
Tomorrow, the newest member of the Learjet family will take to the skies. It's the morning of the first flight. Pilot Paul McCluskey is at the controls for this vital test.
Production first flight, we want to make sure the aircraft's airworthy. So we're going to go take it up, run it through a series of engineering tests.
Paul and co-pilot Scott Runyon have the most dangerous jobs at the factory. They must trust their lives to the quality of work carried out by their colleagues.
It's been a structure, it's been a piece of aluminum, and now it's been shaped and formed, and all the mechanical aspects have been put together, and it's become a flying aircraft.
This first flight is known as the green flight because green primer paint is still visible on the aircraft.
Hello, ground Lear 45, over. Hey, ground to Talker 2 to
Best versus are checked. Straight on.
Go ahead, turn on. Uber Charlie, hold short of 1 left, that's Charlie, Learjet 62.
Runway 1 right, by runway heading, clear for takeoff.
Yeah, for takeoff.
Paul pushes the throttles forward. The aircraft accelerates to over 250 kilometers per hour for its first takeoff.
One, runway 1 right,
rotate.
The plane climbs at the rate of a 10-story building every second before leveling out at 17,000 feet.
Braking now.
It will be in the air for over 2 hours as the pilots test every onboard system and put David Morgan's plane through a series of emergency procedures.
Climb Apollo 230, Learjet 62. Other aircraft again.
First up, the landing gear. It's an anxious moment. Having no wheels would make landing this $14 million jet risky at best.
55 heading 320. You ready? 3.3 for 5,000. Here we go. Gears down, no steer, gets armed automatically.
Relief. The landing gear works just fine.
Good with that? Yep. All right, the gear's up, the flaps are up.
Paul performs a further 500 operational tests.
Let's go ahead and knock up the electrical now.
Okay. Left and right gens.
Next, he shuts down the jet's main power to test a worst-case electrical failure.
Batteries 1 and 2 to off.
Okay.
With the main avionics turned off, Paul is flying with the most basic cockpit instruments.
There's my EDI. It's all we have left.
Test complete, he switches the power back on. So far, so good. Next, the most dangerous check. The stall test. Stalls are responsible for more air crashes than any other emergency scenario. Aircraft stall if they lose speed or climb too steeply. This causes the wings to stop producing lift, the force that keeps them in the air. Without lift, any aircraft would literally drop like a stone. Paul needs to know whether this 60XR can handle a deliberate stall.
You all set? I am. Here we go.
With the engines in idle, he reduces airspeed by pulling up the nose.
Come on, trim. You ready? Five, 4, 3, 2.
At 105 knots, the indicator turns red. The plane is now stalled. It's plunging towards the Earth at over 7 meters per second. Paul must get airflow back over the wings to regain control.
Recovering.
Success. Now back to base.
Clear to 62, good shot there, runway 19 right, clear to land.
Clear to land, 19 right, later to 62.
Once on the ground, the test pilots will file a detailed report for the flight engineers.
Coming up on 18-1.
David Morgan's Learjet has earned its stripes. And it's now time for a trip to the paint shop to put them on. This plane will spend the next 14 days here. Before any paint is applied, the jet's skin needs toughening up with a toxic acid. Iodine is sprayed on every metal surface. It reacts with the aluminium skin, causing it to harden and also creating the perfect priming surface. But time is ticking. The technicians have just 15 minutes before the acid turns from friend to foe. Rather than continuing to toughen the metal, it starts to attack the surface beneath. It must be hosed off before there's permanent damage to the aircraft. Four hours of drying in a heated booth. And a two-man paint team applies the primer. It takes just 45 minutes to cover the tail, wing and fuselage. Then a further 2 coats of surfacer. Together, these layers provide a smooth, corrosion-proof base. Next, the 15,000 rivet indentations are filled and sanded back. Once all traces of paint dust are removed, the polyurethane top coat is mixed with thinners, ready for a 4-hour spray job. This high gloss finish is incredibly tough, able to withstand temperatures ranging from -45 to 50 degrees Celsius. In all, 182 litres of paint will be applied to this plane before 60% is sanded off. This achieves two Learjet hallmarks, a stunning paint job and, crucially, a lighter aircraft. Finally, the custom paint job is hand-buffed. Now it's time to finesse the interior. Here in the Interiors Gallery, Robert Stockton is on hand to guide customers through a myriad of choices.
To meet their needs is very specific, but as you can see behind me, we have plenty of materials.
Leather for seats, wool for carpets, wood veneers for cabinets. Given enough money, anything is possible.
If you can dream it, we can build it for you.
Wow, there's so many fabrics here. I can't believe the selection. How are we ever gonna find the things that will go in our plane?
That's what I'm here to help.
Today, Robert is helping Morgan Company President Grant Opperman finalize his interior choices.
They expect to see the best of the best, highest quality. They want to be wowed. By the time they sit in that seat, they want to be comfortable. They want to have everything at their fingertips.
I think that's us.
Really, really nice.
But that works for me.
Once the client has settled on a scheme, the completions team go to work. It's here that fitting out and any final tweaks are made. A self-service galley is the first step in turning this empty fuselage into a luxury cabin. The 60XR seats up to 8 passengers. They'll be entertained in style with flat-screen TVs and Wi-Fi, while their champagne cools in the minibar.
People, what they want is their yachts, their houses, their cars, their planes to look and feel the same.
This plane is finally ready. And just in time. Multi-millionaire businessman David Morgan and his wife Pally have flown in from their home in California. They're expecting to take delivery of their very own 60XR today.
Wow. Oh my gosh.
For his business to survive, General Manager Ralph Axe needs customers to be happy.
Good to see you. Good. David, good to see you again. So what do you think?
Incredible. Oh my gosh.
All yours.
Beautiful thing I've ever
All
seen.
yours. Ready for you.
I love the way it came out. Absolutely gorgeous. Absolutely beautiful.
Cheers.
Cheers.
Great. On board. On board.
Bye.
Right?
This is beautiful. Wow. Oh my gosh.
Holy Toledo. This is great.
Oh, this is perfect. When you look at what they start with and all the phases that they go through, and you think, I'm never going to fly in a plane that starts like that, but they get it together and it looks like this. It's amazing. It smells like a new jet, however that would smell.
I have a tingly feeling up and down my spine with the thought of being able to take off in this aircraft. It's just an incredible feeling.
Learjet is surviving these tough economic times by delivering hand-built dreams to their customers.
It can be anything for anyone because it can be that luxury toy that you want. At the same time, it could be that workhorse that you need.
This megafactory has been transformed to compete in the 21st century.
It is all about innovation. It is all about excitement. You know, you want to be different. You want to be special.
The 60XR realizes those ambitions.
It's more than just the product, it's the history and it's the culture and it's being around people that want to be innovative and creative and create a product that customers want to fly.
I go all over the world. I could say the word Learjet. Everybody knows Learjet, which is actually really cool.
Don't miss a Megafactories premiere tonight at 8 right here on National Geographic Channel. Stay tuned for a gripping air crash investigation.